On this week's MetPy Monday, we're going to look at our sounding caching service that we built last week and build on that a little bit more with some file lifecycle controls and some error checking. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for NSF Unidata. This week, I wanted to take our sounding caching service that we built last week and expand on that a little bit because, well, it's pretty good as it is, but we can make it even better. And we're going to do that by adding two main features. The first is if we can't get the data from Wyoming, say the server's down or busy or they don't have the data, we'll check the Iowa State archive. And then second, we're going to do some file lifecycle control. Generally, we're researching an event, and then when we're done, we don't access that data anymore. Maybe we don't want that cluttering up our hard drive. Now, in the case of soundings, the files are pretty small, but if this were a geostationary satellite imagery, it could be quite large. So we're going to build a file lifecycle control function that looks at when the file was last accessed, and if it's been over a month, we'll go ahead and get rid of that file. So up here in our imports, this is our notebook we had last week. In addition to importing the date time object, I'm also going to import time delta. We're going to import OS and import time as well. And from siphon.simplewebservice.iowa state, we're going to import the Iowa State upper air object. And we'll go ahead and run that. Our get file name, save to cache, and load from cache functions are all going to remain exactly as they did last week. There's nothing to change there. But for get sounding data, here's where I'm requesting data from Wyoming exclusively. I want to keep this function relatively simple, so I'm going to add another function here that is called fetch sounding. And fetch sounding is going to take the date, which is a datetime object. It's going to take the station, which is a string, just like what we've done before with get sounding data. And it's going to return to me a data frame. What this is going to do is get sounding data from the remote source, or sources, trying Wyoming and Iowa. Okay, so we're going to first try the Wyoming upper air archive. I'm going to return Wyoming upper air dot request data, date and station. I'm going to, on the accept, we'll say accept exception as Wyoming error. We could get more specific with our exception, but here I just want to catch any exception coming from this. I'm going to print Wyoming failed and our error so we can see what happened. And then inside that except, we're going to try returning Iowa State upper air dot request data for the date and station, and accept exception as Iowa State error. Going to print Iowa failed, and we will print the reason that Iowa failed, and we'll make that an F string. And finally, since both of our data sources have failed, I'm going to raise a runtime error of failed to get sounding. Okay, so this function, though there's a lot of try and excepts in here, the logic is pretty straightforward to follow. We're going to try Wyoming first. If that doesn't work, we're going to tell the user why it didn't work and then try Iowa. And if that doesn't work, we'll tell the user why that didn't work and raise an error so that whatever program is calling this stops. And you could catch that error and do whatever you wanted with it. Okay, so now we need to look into our get sounding data function down here that already exists and modify it. So what we're going to do, we're checking if the file exists, loading existing. Okay, downloading new data. So here's where we want to modify things. We're going to call our fetch sounding function that we just wrote. And let's try it out. So I'm going to put in a different date here. Downloading new data, and as it so happens, right now we're not able to get data from Wyoming. We're getting a 503. So we instead went to Iowa and we saved data to cache. So we were able to still get the data and save it to our cache, even though right now the Wyoming server is not accessible. So that function works great, and we've now made our tool much more useful. So it's time to tackle our second bit of challenge in this, which is adding our cleanup. So I'm going to go back up here to where all of my functions are living. Okay, so I'm going to create a function called cleanup old cache. It's going to take our cache directory, which is a path object, path, and it's going to take an expiration. And I'll put that in days. And that is going to be an integer, and we'll set it to 30 unless otherwise specified. It's going to look at the current time, and then we're going to calculate the expiration in seconds. And that's going to be our expiration days times the number of seconds in a day, which, as all geoscientists we have memorized, is 86,400. So now we're going to look at all of the files and compare the last accessed time. And if it's more than our expiration seconds, we'll delete that file. All right, so we'll indent there, and for file in our cache directory.glob, star.text, and we could put in here any number of extensions if we wanted to have a different path. So if we go back up here and look, we're creating our file names as .text, but we could have .csv or .netcdf, anything that you want to manage. The last time that the file was accessed. Now this is actually stored by the operating system, and if we look at the operating system stats on our file object, there's an attribute called statime, which is the stat of the last accessed time. And there's a list in the documentation of all of these interesting stats that you can get on files, but this is really handy for our purpose. So if now minus the last access time is greater than our expiration in seconds, it's time to delete that file. And to do that, we simply call unlink. And unlink is going to remove that file from our file system. And that's all there is to it. So when should we run this? Well, we could run it every time we call get sounding data, but that's probably not going to be the best, because if we have a lot of files in our archive, every time we want to get a new file, whether it's in the cache or not, we have to go through all of the files in this for loop. That's probably not the best. We could do it once per instance of using our caching tool here, but then we need to get into some object-oriented programming and store some state. So I don't want to do that. Our tool is nice and simple right now, though we may make it object-oriented later. So how else could we do this? Well, I think the way I'm going to approach it is saying that I want to run the cleanup once per day because we're only checking in numbers of whole days anyway. I don't really care about fractional days of data. And it's only going to run, obviously, when I use the get sounding data function here. So I'm going to have a little marker file, and I'm going to create a new function for that. I'm going to call it should run cleanup. It's going to take our cache directory, which is a path, and it's going to return a Boolean of if we should run the cleanup. Determines if cleanup needs to be run, will only run once per day. Okay, so to do that, I'm going to have a marker file that's in our cache directory, and I'm going to create a dot file or a hidden file called cleanup marker. So if that marker file does not exist, then we need to run it. We don't have the marker file. We don't know when the last time the cleanup was run, but we need to do it now. If that marker file does exist, we're going to get the last time the cleanup was run by calling datetime.fromTimestamp. Our marker file .stat stmtime, the last modified time of our marker file. And I'm going to return if datetime.now minus the last time that the cleanup was run in days is greater than or equal to 1. Oh, and we forgot our semicolon there. Okay. So now in our cleanup old cache, once we have run this cleanup, we need to update when that the cleanup has been run, update our marker file. So our marker file, I'm actually just going to copy this line from here. And then I'm going to call markerfile.touch, which will update the last modified time of the file. And finally, we need to look at our getSoundingData function. So we're checking that our cache exists, or we're creating it if it doesn't. And next we need to run cleanup if needed. And then we'll come down here and we'll get the data. Okay, so for our running the cleanup, we're going to call our should run cleanup given our cache directory. And if that's true, then we should clean up old cache on the cache directory. And we could update, if we wanted a different number of expiration days, we could set that here. Just so we know it's working, I'm going to print running cleanup. Okay, so we're running cleanup, and then we load our existing from cache. If I run this again, we see that running cleanup disappears because we've now created that marker file that we're using to determine if we need to run the cleanup. If I now pick a different sounding, again, we see that Wyoming is still not working, but we are getting that data from Iowa, and we're not doing anything with cleanup because we've already run for today. Now, if I were to go into this directory and delete my cleanup marker and run again, now we see that it's running cleanup, and then it loads that file from the cache. So with just a few more lines of code and a couple of functions, we've been able to add both file lifecycle management and some redundancy in terms of data sources to our sounding data caching engine. I hope that you found this useful, and I'll see you on next week's MetPy Monday.